This is the third problem on the set of min-max problems that I gave you. I think probably the third problem is the most difficult of the first four. It takes a little bit more flexibility of thinking when you're thinking about triangles, and that's the tough part. It starts out pretty easy. You remember that an isosceles triangle has two sides the same. So when I set my variables, I'll just go right ahead and make those both the same. There's my isosceles triangle. Some people want to make it an isosceles right triangle, but it's not. There might be. We don't know. It's just an isosceles triangle. Perimeter is the distance around. It's 24 inches, so that's my constraint. So 2 y's and an x makes 24. The problem states you want to find the maximum area, so there's our target, maximum area. And the area of a triangle, we have 3 different possibilities to choose from. That's the most common. Some people will use that formula that we learned in geometry, which is so valuable. Area is 1/2 AB sine C. The problem with that is it introduces another variable. You'd need to know one of the angles or be able to find the angle in terms of the other sides. So that's probably not going to be it. And then the third one is Heron's formula, which I personally use so seldom that I will get it wrong if I write it down. It actually would be handy in this problem, but we can get by without it. So let's just stick with 1/2 A, 1/2 BH, and live with that. Okay. So B is going to be the base. We'll let that X be the base. But the height is actually right there. Now, here's the tricky part that requires experience. If you're looking at this video, you've tried the problem a few times, and you probably got caught in the algebra. Like I said in the first video, variables are cheap, and you can throw them away and make them mean something else. So I'm going to, instead of letting x be the side of the triangle, I'm going to let x be half of the side of a triangle. That's pretty clever. It means I have to change my constraint so that 2y plus 2x is 24. But that's a small price to pay. So area is going to be 1/2 times 2x times h. And you can see that decision's already paying off by getting 1/2 times 2, and they cancel out. Now, the problem is that h is a new variable, and we need to have some relationship between y and x and h. You need to train yourself to look for right angles so that you can use the Pythagorean theorem or to use sine, cosine, and tangent. And that's just what we have. X squared plus h squared is y squared. So we can get rid of that h that we had to introduce by solving the Pythagorean theorem for h. So h squared is y squared minus x squared. H is the square root of y squared minus x squared. And most of you on the last test demonstrated that you know you cannot cancel those square roots and squares because of the order of arithmetic and that minus sign. Or you felt the sting of losing some points. So you know that you cannot simplify h at this point. There I've substituted the square root of x squared, or y squared minus x squared. I've substituted that for h. I got that. I still have two variables. That's still a problem. But I haven't used the perimeter constraint yet. So I'm going to bring that down. 2y plus 2x is 24. And I need to either eliminate the x or the y. Since I have the y just in one spot, I'm going to go ahead and solve for y. The quick first step, divide everything by 2 and spell plus correctly. And then subtract the x. Y is 12 minus x. All right. So I get area is x times the square root of 12 minus x squared minus x squared. So at this point in our calculus careers, when we're using the calculator, I think I just go with that expression. Later when we do analytical calculus, we're going to find the derivative and do all those kinds of techniques. We'll simplify that. But for right now, that's what I'm going with. X times the square root looks like my calculator betrayed me. X times the square root of 12 minus x squared minus x squared. There, it probably took you less time. Once again, we want to think about our window. X stands for half the length of the side. It's 24 all the way around. So my problem looks like this. So x plus y is 12. Oh, I've got that right here. So a good number for x min, 0. And then a good number for x max. I think 10 is going to work just fine. Y stands for the area. So let's go from 0 to, how about, if x is about 10, 20 by 10 divided by 2. Let's go with 100, just to see if that flies. And you can see the maximum and interpret the results. So that's the main points for problem number 3. Looking for the Pythagorean theorem was one key. Being open-minded about your variables and willing to change them to simplify the algebra is another key.